5 times more of the universe is made of something we have never seen, never caught, and still cannot name. It does not glow. It does not block light. It does not shine, reflect, or burn. And yet it outweighs every star, every planet, every atom you have ever touched by a factor of 5 to 1. It is the invisible scaffolding that lets galaxies exist at all. So here is the question that has haunted physics for half a century. What is the invisible stuff that holds the universe together? Start with something simple. A galaxy spins. The stars near the bright center wheel around quickly, and the stars far out at the edge should, by every rule we know, move slower. The way the outer planets of our solar system drift lazily compared to Mercury, that is how gravity works when the mass is where the light is. But that is not what we see. In the 1970s, the American astronomer Vera Rubin, working with her colleague Kent Ford, measured the spin of galaxy after galaxy, and she found something that should not have been possible. The stars at the edge were moving just as fast as the stars near the core. The graph that should have sloped gently downward toward the rim instead ran flat, stubbornly, refusing to fall. The galaxies were spinning so fast that, with only their visible stars to hold them, they should have flung themselves apart long ago. They should have unraveled like a carousel spun past its limit, hurling its riders into the dark. Something unseen was holding them together. Something with mass, reaching far beyond the glow of the stars, out into the apparent emptiness past the visible disk. When you add up how much extra gravity is needed to keep those galaxies whole, the answer is staggering. There is roughly 5 times more mass in a galaxy than everything we can actually see. The bright spiral you photograph is just the cream on the surface of a much larger invisible body. The stars are the part that happens to light up. Most of the galaxy, it turns out, is in the dark. This is verified. It is not one telescope, not one strange galaxy. It is the same pattern in galaxy after galaxy across the sky, and it has held up for 50 years. And the spin of galaxies is only the first clue. The second clue is written in light itself. Mass bends light. This is one of the strongest predictions of Einstein's general relativity, and it has been confirmed again and again. A heavy object warps the space around it, and a beam of light passing nearby curves, like a marble rolling across a stretched sheet. Astronomers call it gravitational lensing. So we point our telescopes at enormous clusters of galaxies and watch how they bend the light of even more distant galaxies behind them. The background galaxies appear stretched, smeared into thin, glowing arcs, sometimes multiplied into ghostly copies of themselves. The distortion is not random. Its precise shape tells us exactly how much mass is doing the bending and where that mass sits. And once again, the mass we measure from the warping of light is far greater than the mass we can see in stars and gas. Far greater. The same missing 5 to 1, written a second way, in a completely independent kind of measurement that has nothing to do with how galaxies spin. 2 roads arriving at the same impossible total. Then came the clearest sign of all. A place called the Bullet Cluster. The wreckage of 2 galaxy clusters that smashed through each other about 3.8 billion light-years away. When they collided, the ordinary matter, the hot gas, slammed together and slowed down, glowing in X-rays, piling up in the middle. But the gravity, mapped through lensing, did not pile up in the middle. It sailed straight through and ended up on either side, separated from the visible gas. In 2006, a paper described this with a title that did not hold back: A Direct Empirical Proof of the Existence of Dark Matter. And in the years since, even the James Webb Space Telescope has returned to the bullet cluster to refine the picture, and the separation is still there. So this is the verified core of the story. And it is worth saying plainly: we know there is far more gravity in the universe than the visible matter can account for. We see it in how galaxies spin, in how clusters bend light, in the cosmic collision that pulled gravity and gas apart. The evidence is overwhelming. Something is there, and it is everywhere. Zoom out far enough, past single galaxies, past clusters, until whole galaxies shrink to points of light, and the entire universe reveals a hidden architecture. It is threaded with vast filaments, a cosmic web, with galaxies strung along glowing strands like dew on a spider's silk, and great dark voids yawning between them. The shape of that web, the way structure first clumped and grew in the hundreds of millions of years after the Big Bang, only makes sense if there was extra unseen mass acting as the scaffolding. Dark matter, unbothered by light and pressure, clumped first, and its gravity then pulled ordinary gas down into the bright places we now call galaxies. Without that invisible framework laid down early, the cosmos would be a thin, smooth fog, with no galaxies, no stars, and no one here to wonder about any of it. Tally it all up, and the books are strange. Everything you can see, every star and planet and person, is only about 5% of the universe. Dark matter is roughly 27%. The rest, around 68%, is the even stranger dark energy. The matter we understand is a thin, bright film on a dark ocean. So the verified part is solid. Now we cross a line into theory, because knowing that something is there is not the same as knowing what it is. For decades, the favorite suspect had a name: the WIMP, a weakly interacting massive particle. It was an elegant idea, a heavy, sluggish particle, left over from the Big Bang, that almost never touches ordinary matter, but just occasionally, very rarely, might nudge a single atom in a detector deep underground. So we built those detectors, tank after tank of liquid-xenon, buried beneath mountains to shield them from everything but dark matter itself. And here is where honesty matters. After decades of searching, the WIMP has not shown up. The leading experiment, called LZ, released its most sensitive results in December of 2025. The largest dark matter dataset ever collected, more than 400 days of watching, and it found no dark matter particles at all. Instead, it began detecting neutrinos streaming from the core of our own sun. A sign that these detectors are now so sensitive they are bumping against the faint background hum of the cosmos itself. Each new detector is more sensitive than the last, and each one comes back empty. The space where the WIMP was supposed to live is being squeezed almost shut. The most elegant guess in physics is quietly running out of room, and a generation of physicists who bet their careers on it are having to face that possibility honestly. But the searchers did not give up. They changed targets. Increasingly, the spotlight has turned to a different, far lighter ghost, a particle called the axion. The axion was not invented to explain dark matter. It was proposed to fix a completely separate puzzle in the equations of the strong nuclear force. But physicists realized that if it exists, it would have been produced in enormous numbers in the early universe, and it would behave exactly like the cold, invisible mass we are missing. Two mysteries, possibly solved by one particle. The problem is that an axion would be fantastically light and fantastically shy, far too faint to spot the way we hunted WIMPs. So the hunt has become a feat of quantum engineering. Experiments like ADMX chill their equipment to a whisper above absolute zero and use exquisitely sensitive quantum amplifiers to listen for the almost imperceptible signal an axion might make as it converts into a flicker of light inside a strong magnetic field. In 2026, new results from networks of quantum sensors are pushing this search to a precision that would have been unthinkable a generation ago. We are, quite literally, building instruments quiet enough to hear a particle that may not even be there. And that brings us to the honest edge of all of this. The open question. Here is the truth that no documentary should hide from you. Dark matter has never been directly detected. Not once. Everything we know about it, we know from its gravity, from the way it pushes and pulls on things we can see. We have never held a piece of it, never caught a single particle in the act, never made it in a collider, never seen it decay. We do not know its mass. We do not know if it is one kind of particle or many, or whether it interacts with itself or feels any force at all besides gravity. We have a mountain of evidence that something is there, taller and firmer every year, and almost no idea what that something actually is. It is one of the most lopsided situations in all of science. Overwhelming proof of the effect, total silence on the cause. And so a smaller group of physicists asks a braver question. What if there is no missing particle at all? What if, instead, our theory of gravity itself is incomplete, breaking down ever so slightly at the vast, faint scales of galaxies? This idea, modified gravity, remains very much a minority view. It struggles to explain the cosmic web, and it struggles most of all with the bullet cluster, where gravity and visible matter came apart. Recent studies of tiny dwarf galaxies in 2025 tipped the scales further toward real dark matter and away from modified gravity. But the dissenters point out, fairly, that until someone actually catches a particle, the case is not fully closed. So what is the honest answer to our question? What is the invisible stuff that holds the universe together? The honest answer is this. We know with great confidence that it is there. We can map it, weigh it, watch it sculpt entire galaxies and stretch the cosmic web across billions of light years. It is 5 times more abundant than everything we can see. And without it, the universe as we know it could not hold together. But what it actually is, the thing itself, remains the single greatest unsolved mystery in physics. We have spent 50 years describing a ghost we have never met. And maybe that is the most human part of this story. We built a complete picture of a universe that is mostly invisible to us. We learned to feel the weight of something we cannot see, to map a continent by the shadow it casts. Right now, in laboratories deep underground and cooled to near absolute zero, people are listening, patiently, year after year, for the faintest possible whisper of an answer. They tend instruments that may sit silent for an entire human lifetime. One day that whisper may come, and a single click in a detector could rewrite the textbooks. Or it may never come at all, and the answer may turn out to be something none of us has yet imagined. Until then, we live inside a cosmos held together by something with no name, looking up at a sky that is far heavier and far stranger than it looks. If you want the universe told this way, with the wonder kept honest and the uncertainty left in, this channel publishes the honest cosmos every week. Subscribe and stay in the dark with us a little longer. One question before you go. If we someday prove that dark matter is real but learn we can never see it or touch it, would that feel like an answer to you, or like a deeper mystery? Tell me in the comments.